applications. And I'm currently working at HORIBA Japan in Kyoto and joining this webinar from here. Let me move forward. The agenda for today's seminar is firstly, I want to talk about the general specifications of the product, and then I will move on to what are the benefits our product can provide you. And then lastly, but the most importantly, I will introduce some of the case studies that we've done in the previous projects. And during my session, you can, if you have any question, please do not hesitate to, I think, post in the chat so that I will check and get back to you. You can ask me any question at any time. Right? If there's any unclear point that you couldn't understand, please also let us know. All right. So, yeah, firstly, let's talk about what is PX375. That's an ambient multi-metals monitor. One system is composed of sampling unit, PM mass concentration analysis, and also metal concentration analysis, all in one unit. And mass concentration stands for the concentration of the PM, and then metals are the composition breakdown of PM. And we use beta ray attenuation technology for PM mass analysis, and then we also use XRF technology for metal analysis. The unique point of the instrument is it's an automatic near real-time analysis, and you can set the shortest sampling time as 30 minutes. Thanks to the features of the instrument, you can continuously monitor the pollution and visualize the time trends. Later on, I would introduce how this feature can actually contribute to your research or your work. Let's look at animation and learn how the instrument works. So there's always a PM pollution in ambient, and it's taken from the sampling head at the top. And once the PM sample is taken into the instrument, that will be trapped on the surface of the filter tape. And at this location, mass concentration is analyzed with the beta ray attenuation technology. And then it's moved forward to the next position where metal concentration is analyzed with X-ray fluorescence technology. With the if you install PM PX375, you will get a lot of measurement data such as PM mass concentration, metal concentration. And if you also install other sensors like wind speed, humidity, wind direction, GPS, and temperature, you'll be stuck with tons of data. And not just the instrument, but we also have proposal of data management system, which is called EcoWeb. And with this software, you can check the time trend and geographical information too. Not just that, you can also show the time trend of multiple metals. And if you want to visualize the measurement data, basically, in the very manual method, you have to put all the measurement data onto a CSV file format, and then you have to manually put it into uh, the graphs. It's such a time-taking process. And you can also take a monthly report from the software, and together with the wind speed, wind direction measurement data, you can also visualize from which direction the particular concentration of the metal is coming from. So if you put this data onto the map, you can uh, uh, visually see where is the how much pollution is detected at the measurement site, and from which direction the pollution is coming from. And then you can also check what is the facility uh, uh, possibly causing the pollution in that direction. Histogram data. And if you also want to put it online, you can get it online through Wi-Fi communication, and you can check this data all remotely. Okay, from this slide, let's learn a little bit about what is the um, what how important the metal elements in the total particulate matter. So as you're seeing, particulate matter is composed of a lot of elements, and uh, if you roughly break it down, you have uh, iron element, metal element, and elemental or organic carbons. And the reason why PX is for metal analysis is that uh, metal component does not change the composition uh, in the during the transportation. For example, if you are monitoring SO2 value, the composition concentration will change over the time during the transportation, getting the, for example, sunshine effect and so on. But on the other hand, metal doesn't change the chemical composition during transportation. So that's why they can work as a good fingerprints for pollution source analysis. If the composition changes all the time, you can get no clue where they came from. But if the composition doesn't change, uh, that information is saved from the origin of the pollution all the way up to the location you detected the pollution. That's the very important point why we want to monitor metals in ambient. And in some studies, of course, the importance of metal analysis is already known. That's why other researches were taken before. But the method used for the projects in the past is very conventional. For example, you have to have a sampling unit like the photo here, and then you have to take the sample on the filter and take it to a pre-treatment process. And then finally, you can analyze the, the sample. So as you're seeing, obviously it's a expert analysis. That's why it's expensive. It takes most of the cases. It's very rare that you have the analysis instrument in your lab. So most of the cases, you have to take the sample and ship it to the analysis lab. and wait for a certain time until you get the analysis results back. So this process is very time consuming. It normally takes about 2 weeks to 3 weeks. That's why it is very difficult to grasp trends with high frequency. This the measurement frequency is a key point for today's webinar. So let's look at the benefits of online XRF metal monitor. So as I explained in the previous slide, the conventional method used is ICP-MS in many cases. Time resolution wise, usually measurement frequency is 24 hours. In other words, you can only analyze one sample in a day. On the other hand, PX that equips XRF technology, you can analyze the sample every 30 minutes shortest. The good point about this is that you can analyze the trend of pollution by time of day. For example, in the rush hour, more vehicles are running on the highway than the normal daytime. So there must be a certain unique rapid outbreak of a specific specific pollution that's coming from vehicle, for example, tire or brake. So such activity cannot be captured with a manual method, but with XRF online monitor, you can capture a short-term rapid increase in concentration. The next point is pre-treatment. As explained, you need a professional pre-treatment process for ICP-MS, but for online XRF monitor, that's automatic, so no need for a pre-treatment process. Thanks to this benefit, you can reduce the amount hours required for analysis, and it is also easy to install. The next one, number of data. Because of same reason as a time resolution, for manual analysis, you can only get one measurement data in a day, but with online XRF monitor, you can get many measurement data in a day. For example, if you set the measurement frequency every 30 minutes, you can get 48 measurement data. The good thing about this is recently data analysis approach to environmental pollution is very common and popular. In order to get a good accuracy of the analysis model, it's better to have many data. Lastly, but very importantly, promptness of the measurement is important. As I explained, for the conventional method, you have to wait until you get the analysis result back. But for online monitor, of course, since it's online, you can get the measurement result nearly real time. So by this benefit, you can do smooth verification of your idea. For example, let's say you have an idea of a pollution analysis and you want to apply it. But if you have to wait for 2 weeks, the condition already changes and you cannot duplicate the same condition again, never. But if you can get real-time measurement feedback, you can easily apply your idea and verify your idea quickly. So with the new technology, you can do something you were never able to do it before. Okay, let's move on. From this page, in this page, uh, I wanted to emphasize how measurement result will look different than the conventional method. This is the data taken from Ministry of Environment Japan. The bottom graph is showing the trend data by manual method, and the upper side is showing you the continuous measurement data of PX375. Just for your information, PX375 is also installed in one of the AQMS stations of the Ministry of Environment Japan. So please look at the yellow bar. Since the manual analysis is 1 day average, the sharp peak there, the rapid outbreak of titanium concentration is not captured. So this is one of the typical examples how the continuous measurement is beneficial to users. Okay. Uh, do you have any questions so far? If you have any question, please, you can write a comment in the chat. All right. Seems like so far so good. Let me move forward. So from this slide, I'll be talking about the applications, the actual projects where PX was used. The first case is advanced research of pollution generation mechanism and trans-boundary air pollution by the Ministry of Environment Japan. In Japan, more than 1,900 AQMS is installed. And that's why, of course, we've been monitoring PM 2.5 concentration over the past years. And we are successfully improving on the PM 2.5 concentration overall. But there are still some areas where environmental standard is not achieved for short time period. The Ministry of Environment Japan wanted to learn the mechanism how we can possibly improve the rest of areas. So PX was installed in 4 locations in Japan, as you're seeing on the map here. The previous challenges for the customer was a limited number of analysis data of manual method. And that's why it was difficult to capture rapid outbreak of a certain metal concentration. And this was a case where the benefits of the instrument are best matched. So PX provides you mass metal monitor continuously, simultaneously, and that was very important information for learning further contamination generation mechanism. And also high time resolution of the monitor was a key factor to get the information which is reflecting different activities of pollution in different time in the day, like just like the rush hour case I explained earlier. This is the measurement result data. As you see on the left chart, we have the black trend. That's a manual method, and red graph is a PX data. So as you're seeing, we have very good correlation. And if you look in the number, the R square was 0.96 for this case. Okay, let's move on to next case. That was a wide area pollution analysis research by analysis of PM2.5 high concentration events by simultaneous observation of particle elements composition and dative ratio. We call it OR. I think I think you will find this approach very unique. It's a it's a research taking place in Japan, and this graph is showing the black graph is PM 2.5 concentration, and the red graph is um, lead zinc ratio. I think you're wondering what is lead zinc ratio. Lead zinc ratio is lead concentration divided by zinc concentration. Why do we do it? Uh, lead is um, lead is generated greatly from, for example, coal firing facility, but zinc is basically stable in concentration, uh, regardless of the place, Japan or China. So if you are monitoring this ratio, you can monitor uh, when you have great pollution from coal firing facility. All right, and in the study of um, uh, in a lot of studies in Japan, it was thought that PM 2.5 PM 2.5 was coming from overseas. But if you look at the trend graph here, PM 2.5 trend and lead zinc ratio is not really correlating. When PM is increasing, lead zinc ratio is staying low, which is telling you that this increase of PM 2.5 is because of something happening in Japan. All right. Usually, when lead zinc ratio is higher than 0.44, it's considered that coal firing facility from overseas is affecting greatly. But when you look at the red graph, getting close to four, getting close to the lead zinc ratio higher than 0.4, the PM 2.5 is not really increasing. So this study was an example of proof that the conventional analysis approach still include room for improvement. And not just the PM metal analysis, the researcher here also applied another theory. It's a OR, oxidative ratio. And similar to lead zinc ratio, certain combustion fuel has oxidation OR features. For example, if you if you uh, if you use LNG for your fuel, OR ratio will tend to be closer to 2. And if you're using LPG, it's a 1.4. And if you're using coal as fuel, OR ratio is low. So let's look at the yellow bars here again. Those are the two time duration where the PM was increased in Japan, but lead zinc ratio is not high. That's why those PM increase is due to some activities in Japan. And let's look at the OR ratio for the two events. For the first event, OR ratio is close to which one? For me, it looks like it's close to the coal. The second event is 1.58. So it is close to LPG fuel. So just like this, you can analyze and estimate where the contamination source is. And those knowledge and experience is needed for the source apportionment analysis. And metals and HORIBA analyzers, not just PX, will be contributing to the research. The next one is source apportionment of mercury pollution. And sometimes mercury is a key topic because in the raw material, for example, coal includes mercury in the raw material, and it will cause pollution afterwards. Atmospheric mercury behavior is studied for a long time. And in Japan, we also monitor the time, also monitor the trend over the years. They are composed of three phases, I would say. Um, Elemental mercury, in other words, metal mercury, is the important factor because, again, it will not change the chemical composition in the air. And what's more, if you look at the breakdown of mercury phases, uh, I'm looking at right here. Metal mercury is composed of most of the percentage of mercury in ambient. So basically, if you're monitoring metal mercury, you are covering the behavior of ambient mercury mostly. And yes. Yes. And in the research before, of course, uh, mercury in ambient was monitored. And recently, some suppliers also have continuous ambient mercury monitor, but it's only meant for mercury monitor. So just to check the health impact of mercury, it's good enough. But the point is, uh, if you have additional information of the other metals, you can conduct source apportionment approach. You can learn where the mercury is coming from. Let me explain how it is in this slide. For example, uh, I uh, I picked up some of the representative indicators for each mercury source. Major mercury source generation are coal, coal firing facility, cement industry, incinerator, or sometimes sand, heavy oil combustion. So let's focus on the coal firing facility and cement plants today. I put the measurement results of uh, mercury as right here, and we want to know uh, is this mercury concentration correlating with coal firing facility or cement facility? And for coal firing facility, as we learned in the earlier, we can use lead zinc ratio. And for cement plant, we can use the concentration of calcium as an indicator of the industry. If you look at the time trend for the first event here, mercury concentration increase is correlating with lead zinc ratio. And the second event is correlating with calcium ratio. So even though you can only see the mercury concentration increase in this time span in 1 day, if you look into the composition of metals, you can learn, or the first event was actually affected greatly from coal, and then the second one was affected from cement facility. So those are the cases where metal concentration information is beneficial to you. The next case is a little bit related to private sectors. It's a baseline monitoring and visualization of metals and mass concentration together with wind speed, wind direction at the steel plant. Oh, the situation was bad. The residents had health damages from PM, and it's very common that residents report to the regional government for example, compensation. But even though everyone knows when PM concentration is high because you can visually see the uh, uh, the dust. But the thing is, no further information was available because they only monitor PM mass concentration. So we installed PX375 and put it into visualization software. So what you can do is the left above map is how PM2.5 is spreading and uh, from which direction more PM2.5 is coming. So this red point in the center, it's a monitoring station we installed PX. And since PX is monitoring PM and metals together, we have three graphs here. If you look at the PM2.5, the chart, the rose chart is spreading to any direction, which is telling you that PM pollution is coming from any direction. And if you see around, here's a steel plant, but just close to the station, you also have highway. So a lot of vehicles are running. And now let's look at for example, sulfur is also coming from any direction. But if you look at the lead and iron, it's typically primarily only coming from the industrial area where the steel plant is existing. So just like this, um, plant operator can get an idea what is the breakdown of the PM, and based on the breakdown information of the PM, they can make connections, correlation with what are the pollution that the the plant, this case steel plant, is generating, and what are the pollution effect coming out from their facility, so that they can draw a line. Okay, this is the responsibility of the plant, and this is not the responsibility of the plant. It was a case for private sector. Uh, uh, I think this is the last application case study. Uh, it's a source apportionment with positive matrix functionalization. It's called the PMF, and I think some of the audience today are familiar with. It's a commonly applied data analysis approach in the pollution source apportionment research domain, and that will provide you, in this case, PM generation contribution ratio of different types of generation sources for given time period. And in order to make this work, you have to have adequate amount of data for as many measurement objectives as possible with reliable accuracy. So in order to apply the analysis method, we actually prepared AQMS, HORIBA AQMS, and installed PX375, and also air pollution monitor AP370 that we use to monitor NOx, SO2, CO2, ozone, total hydrocarbon, and so on. And we use the measurement data of HORIBA AQMS for PMF analysis. And so it's a little small, but after you apply the data to the PMF model, the model will profile the pollution source into a number of factors, and a factor stands for example, like a category. So the PMF will categorizes the pollution source into groups. So please read factor as category here. So let's look at the category number 1 here. As you can see, CO and SO2 concentration are high. Sorry, just for your information, the blue bar here stands for concentration of the parameter, and then red square stands for percentage of the species. So if you sum up all the red square, that will be 100%. Okay, so if you look at all the red squares for category 1, those are the highest, I think. So SO2 and CO are the significant indicators for the category 1. And the PMF also gives you the trend graph of contribution ratio. In other words, if you look at the graph down here, you can see when when category number one pollution source was contributing great to the PM 2.5 generation. And in this case, the possible generation sources that will emit great CO and SO2 are vehicles and oil combustion facilities. So uh, when, of course, you always have PM 2.5 concentration, but if this chart is at the high position, that is telling you uh, the most of the PM generation contribution is because of the facilities such as oil combustion or vehicle. Now, if you look at the second factor category, copper is significantly high, which is telling you the possible pollution source is copper mining or smelting. And let's look at the contribution ratio chart here. It's normally stably low, but all of a sudden you have a outbreak of um, the chart. So maybe there was something wrong with the smelting or mining facility nearby during this certain time period. Just like this, in the government sector and also private sector, the measurement data analysis can help you to identify the pollution source. If you have such information, you can look around the monitoring area and try to find the relevant facility and start discussion with them to improve the environmental quality. Thank you. That was all from my side. And prior to today's webinar, I received some of the questions from the audience today. So I want to answer to them 3 questions. And then finally, I'll move forward to Q&A session. The first question was, do I have a LDL list? So this is the list of LDL. Sorry, I couldn't list up all the elements here because of the limited space, but just for your information. And I can also provide you the full list later. The second one is installation area. I picked up some of the relevant information for you. Not really sure if this really satisfies your question or not, but this is the size of the instrument, and it has the front width of 430 430 millimeters. So if you want to install the instrument in AQMS, you definitely want to have uh, more room than 430 millimeters because otherwise you cannot open the door. And at the rear side, we have data communication connections. So you also want to have a maintenance space here. And if you want to install in cabinet or enclosure, those are the examples. According to the operational installation condition, you want to also install air conditioning unit to sustain the environmental temperature within the proper temperature for the instrument. And if you want to install a display and isolate the external temperature influence. This is also one of the examples. Lastly, sorry, this is not installation, filter tape. That was a question about filter tape. What is the specification of the filter tape? The filter tape is composed of PTFE and PP and PE. And these are, I think, not sure if you need this much details, but average hole diameter is 1 micrometer, and other specs for here. And I think I thought this might be of your interest, blank test results. So if you are also currently doing manual analysis, you might be facing the issue with the contamination in the filter tape. But as you can see, the contaminations contained in the HORIBA patent PTFE filter only contain the reduced contamination, just like you're seeing. Okay, I think I successfully replied to the pre-posted question. Yeah, thank you very much. And now, any other questions?
We have one question in chat. Is PX375 used for compliance monitoring in Japan, such as air quality standards for PM2.5 for metals?
Okay, yeah, let me rephrase the. Soma-san, you wanna lead, or should I just continue?
Yeah, continue with the question in the chat box.
Okay, so a question in the chat box is PX375 used for compliance monitoring in Japan, such as air quality standards for PM2.5 or metals. Honestly saying, there is no continuous air metal monitoring standard in Japan currently. So in simple way, the instrument is not compliant to the standard, but that's because there's no standard.
You mean that in Japan, have the PM 2.5 standard, right? But no have the metal quality monitoring standard.
Oh, right.
And what about the PX 375? Is can use for the PM 2.5 or not? Or just metal analysis only?
PX375 PM mass concentration beta ray attenuation technology. There's a standard. As the technology, we are using the technology that's compliant to the standard, but we haven't applied for how do you call it, certification. So it's not currently compliance, but in most of the cases, it's used for advanced research. So even Ministry of Environment Japan never requested for it before.
Okay, so this one may be okay. Certify the answer. So more question from the register form from Kunamon Pat. She asked about is there any PX 375 currently installed or used in Thailand?
Right now, we do not have installation base in Thailand.
So yeah, but we have the reference unit in China and Japanese, right?
Right.
And Japan Yeah, and any country in the Southeast Asia region, do you have any the reference for this region or not?
Okay, yeah, we have installation, I mean, sales record in Singapore.
So,
Yes.
how many units you have installed in Singapore?
In Singapore, one unit and some other projects moving on.
Okay,
Yes.
that means they have the future plan to more
Right,
install in Singapore, right?
right.
Uh-huh. At this moment, we don't have the reference in Thailand, but we have the demonstration unit
Right.
using in the Genex company.
Mhm.
Genex is our distributor. They have some research and some continuous tests
Mhm.
in their office area at that moment.
Right,
Okay.
right. So yeah, uh, I'm looking forward to that opportunity. Yeah,
Uh,
we are ready to work together with you today.
So anyone have any question for this webinar today webinar? It seems we quite a few person in here.
Mm.
So if nobody have a question on this moment, we will close the webinar. If anyone have a question after this, you can email or just call call on my telephone number as that I send you on the invitation, or just text on the Line application or whatever you want. So after today webinar finish, I will be send the document on the email and the recording video on the YouTube link. So okay, thank you for your time for your presentation and sharing information.
Thank you
So
very
thank you very much. So
Uh,
Oh,
please,
yes,
there is one more question, additional question.
yes, yes, Okasan.
hold on. Yeah.
Oh, sorry. Okay.
Is there any is there any study on laboratory comparison of metals analysis with conventional analysis like ICP-MS? Yes. For example, this is also um, one of the. Oh, I'm still trying to get back to the question. Yeah, this is also one of the comparison tests between lab analysis method and the online XRF monitor. And we are starting research in Japan for comparison test, and also in Germany. I think we can publish the result sometime next year. Yeah.
Yeah, we have some research test, right? So what about the previous presentation? You have shown some information like compare between ICP and the PXT75, right?
Right. Ministry of Environment case, I think.
Yeah.
Yeah, this is also one of the studies. It's you can it's all Japanese, but you can see the result on at the web page of ministry.
Yeah, I will send more information about the research, even in Japan and some case in China that I found on the public white paper.
Hmm.
After this, I will send Kun
Yes.
Amarat again. Kun Amarprat again. Okay.
Okay.
So any question from the ground? Okay. If nobody have any question, I will close the webinar today. So Thank you everyone for joining this webinar, and I hope, really hope this one will be may have the useful for you all guys. If you have any question, you just email or calling to me. Okay. Thank you. Stay tuned and be healthy and be safe. Thank you very much.
Thank you very much, everyone.